Okay, in this video we're going to continue to talk about naming chemical compounds, but this time we're going to focus on ionic compounds. So remember, whenever you're naming compounds, you first have to figure out what your elements are. Do you have a metal, a nonmetal, a transition metal, a polyatomic? What are your elements and how are they bonded? So when I have an ionic compound is when I have a metal bonded to a nonmetal. This means that I have an ionic bond. I'm actually going to transfer electrons from one atom in the compound to the other. So one of my compounds is going to have a slightly positive charge and the other is going to have a slightly negative charge. The one with the positive charge, so the one that is giving up the electron, we call a cation, and it's typically our metal. The one that is taking on that electron or accepting the electron, we call the anion because it's going to have a slightly negative charge, and that's typically going to be our nonmetal. So in an ionic compound, our cation or our metal comes first, and our anion, our nonmetal, comes second in the compound. For our ionic compounds, because we're transferring electrons, I need to make sure that I balance my charges, because even though my elements are going to have slightly positive and negative charges, my overall compound needs to be neutrally charged. And then just like we saw in our binary molecular compounds, they're going to end in "ide." So let's try some practice using these ionic compounds. So again, I check first my lithium, I check on my periodic table, and it's a metal because it's on the left of my periodic table. My sulfur is up in that upper right-hand corner, so I know that it's a nonmetal. So when I have a metal and nonmetal, it's an ionic compound. So the nice thing about ionic compounds is when I'm going from symbol to name, I'm just going to name it. I don't have to worry about any prefixes. Prefixes are only for nonmetal. So I don't have to worry about any prefixes. And when it's in symbolic form, the charges have already been balanced. So all I have to do is name it. So this is just lithium sulfide. Okay, so I'm still going to end in "ide." Down here, I have barium chloride, and my KBr is potassium bromide. So it's really simple when I'm going from symbol to word. Just name it and make sure your compound ends in "ide." So the tricky part comes in naming ionic compounds when I'm going from my name to my symbol. So this is where I have to balance my charges because again, I need to have an overall neutrally charged molecule. So sodium fluoride. So I know sodium is an Na and my fluorine is F. And I check in sodium is a metal and fluorine is a nonmetal. So I have an ionic compound. So when I look at my periodic table, I look at the charges above the groups and I notice that sodium has a +1 charge, which makes sense because it comes first. It's the cation, so it's a positively charged metal. And my fluorine is a -1, which also makes sense. It's the anion, or the negatively charged nonmetal. So if I have one positively charged sodium and I have one negatively charged fluorine, my sodium has a +1, my fluorine has a -1, so I actually am, as is, balanced. So all I have to do is write this as NaF, because I have a +1 from my sodium, a -1 from my fluorine, so all together this molecule is neutral, is neutrally charged. So let's look at calcium nitride. So my calcium and my nitride is going to be nitrogen. So I look at my periodic table and my calcium, above its group number, there is a +2, meaning that calcium has a +2 charge when it forms an ionic bond. Nitrogen has a -3 charge when it forms a bond. So now I'm not balanced. I have a calcium with a +2 and a nitrogen with a -3. So I have to be able to balance these charges. And I can't change the charges. I can only change the quantities of the elements in this molecule. So I can change how many calciums I have, and I can change how many nitrogens I have. And the easiest way to balance this without having to worry about common denominators is to just do my swap and drop. Swap and drop. So I'm going to take my 2, I'm going to swap it to my nitrogen and drop it down. My 3, I'm going to swap it to my calcium and drop it down. And when I drop them down, remember those subscripts are quantities. They mean how many atoms I have. They no longer mean charges, so that plus and minus isn't going to come along. So my 3 has been swapped and dropped to my calcium, and my 2 has been swapped and dropped to my nitrogen. And to double check to see if that works, remember my calciums each have a +2 charge, my nitrogens each have a -3 charge. So if I have 3 calciums, each with a +2 charge, I have an overall +6 charge. And if I have 2 nitrogens, each with a -3 charge, I have an overall -6 charge for my nitrogens. So I have a +6, a -6, so this is now neutrally charged with my 3 calciums and my 2 nitrogens. So I'll do one more example, boron fluoride. So I've got B and F. And if I look at my periodic table, my boron has a +3 charge. My fluorine has a -1 charge. So if I have one boron with a +3 charge, I'm going to actually need 3 fluorines to balance that out. So I'm going to have BF3. So now I have my +3, and even though I don't have to write the 1, I know it's there. So +3 times 1 is a +3, just to double check. My fluorines each have a -1. -1 times 3 is -3. So I have a +3 and -3, so this molecule is balanced. So my answer would just be BF3. Okay, and that was my swap and drop. I took the 1, swapped it to my boron and dropped it down, took my 3, swapped it to my fluorine and dropped it down, which is just an easy shortcut to be able to balance my charges so that my molecule is overall neutrally charged. So I'm going to box your final answer so you don't have to worry about the charges. They're just there to double check to make sure I balanced it correctly. And that's it. That's how to name ionic compounds. If you're just going from symbol to word, just name it, make sure it ends in "ide." If you're going from word or name to symbol, you have to look up your charges and then swap and drop them to balance so that your molecule has an overall neutral charge.